Methodology for the data modeling. In this case, for the supervised machine learning, our team have decided to use the K nearest neighbor. So in this experiment set for the training, at least for the training of the data model, is 6,000 plus instances has been used in order to generate the K nearest neighbor. So later on, the sharing of the performance in detail will be done in the conclusion by my teammate later. So in this case, the K nearest neighbor or the KNN, we have decided to normalize all the features, which is the feedback word count, the sentiments, the positive and as well as the negative. In this case, is actually to help the machine learning to give us a better clustering of the data. So from the testing that we have done, right, we have actually choose 81 and 82 because based on our understanding, the optimal K to be chosen, right, we can actually use the root square of the number of rows for the training set. So in this case, the 65,000 plus, when you root square it, we actually get the number of 81 point something. So in this case, we actually tried with 81 and 82. So based on the data modeling, when we're trying to do some tuning, and if let's say we are using the elbow method, the K20 is actually the most optimal one for it. It has actually the accuracy of 66.86% to be able to predict. So in this case, we'll say that the model is technically, at least as in an overview, this is just an okay type of prediction. So I guess the reason here is due to the conflicting values, which is actually done by the sentiment as well as the positive or the negative value in this case. So I think in the future, if let's say we were to do any more testing, the best feature that we should be using is using the feedback word count with either the positive or negative, but not everything together. Yeah, this is more on the data modeling using the K nearest neighbor. So the next model that we actually use is the K-means unsupervised model. So in this case, based on the thing that we have actually learned from the previous supervised model, we just change the clustering to give a context of having the rating with the feedback of the word count from based on the comment. So in this case, we did get how I call it, three very, I would say that interesting cluster which have a very large radius or the distance. So in this case, one of the interesting observation that we have get here is it seems that whenever the word count is more than 550 words, right, it will be classified as a one cluster. Whereas those that's in between 550 to let's say 250 is actually somewhere in between. Whereas the rest, which is 200 words and below, it will be classified as the latest another cluster. So based on at least the understanding that we have from this graph over here, it seems that the machine learning, it seems that it doesn't pay much how I call that, attention on the rating. In this case, this is actually the rating from 1 star, 2 star, 3 star, 4 star, and 5 star. It seems that based on this distribution and based on the word count for the machine learning, it seems that the comment that really have impact on matters is actually 550 and above. So all this type of data, the one in the middle and the one in the above, right? I think for those people that want to have a impact to actually to fix the website, right? Actually, they can actually explore these two data here. What are the incentive can be done by the Amazon to improve the quality of the comment, or perhaps they just don't have to improve the quality. They just keep on using those with 200 or 300 words and above. These are two clusters to do the to ensure that whether this is impactful or not. So this is actually it's an interesting thing that we can actually, based on this data modeling, we can see that the k-means can actually give us a better context on how these feedback will count and the rating actually behave. So yeah, this conclude the data modeling. The further conclusion will be done by my team member later. So thank you very much and have a good day.